Good evening, everyone. Welcome to Cooper Hewitt. My name is Cristina de Leon. I'm the Associate Curator of Latino Design. I'm so pleased to have Ronald Rael featured in this Diseño program, a series that highlights the achievements of Latino designers working in the United States. Launched into urban reform as a catalyst for economic growth, political equality, and environmental justice. Ronald Rael is an associate professor at UC Berkeley, where he holds joint appointments in the Department of Architecture and the Department of Art Practice. He is an applied architectural researcher, design activist, author, and thought leader in the field of additive manufacturing and earthen architecture. He's also the author of Border Wall as Architecture, a manifesto for the US-Mexico boundary, as well as Earth Architecture. In 2014, his creative practice, Rael San Fratello, with architect Virginia San Fratello, was named Emerging Voice by the Architectural League of New York. Together, they founded Emerging Objects, an independent 3D printing make tank, specializing in 3D printing, architecture, building components, environments, and products. The work Emerging Objects has produced is truly exceptional in its creativity and innovation, and we're actually so lucky to have some of their objects on view now in the Census Design Beyond Vision. So if you haven't visited the show, don't miss it because it closes at the end of October. Following Ronald's presentation, he will engage in a conversation with Patricio del Real, currently an assistant professor of history of art and architecture at Harvard University, and previously he worked in the Department of Architecture and Design at the Museum of Modern Art, where he organized what I believe was really truly a groundbreaking show called Latin America in Construction, Architecture 1955 to 1980. Thank you, Patricio and Ronald, for being here this evening. And thank you all for joining us tonight. I think it's going to be really special. Ronald.
Thank you, everyone. Thank you, Christina. Thanks for coming. Thanks to the Cooper Hewitt for the generous invitation to have me here for the entire day, also in a workshop. And many of you were in the workshop today, and that was a lot of fun. I'm going to talk for 30 minutes about two bodies of deep research that I've been working on for the last 10 years, thinking about the border wall that's constructed between the United States and Mexico, and also the project Printing Architecture, which is about 3D printing with the goals and aspirations of arriving at architectural solutions using that technology. But I wanted to contextualize this a little bit about where I am from, because it has implications in thinking about how this work emerges. I'm from a very particular place in the United States called the Valle de San Luis, which is historically the northernmost frontier of Mexico and the Spanish Empire. It's also the headwaters of the Rio Grande River, which, of course, you know, currently defines the border between the United States and Mexico. But this was the border between the United States and Mexico until 1845. In the next 3 years, Texas had seceded the Union and claimed the land up to the Rio Grande. And that valley was divided in half, with one side being contested territory, Texas territory, and the other side being what remained of Mexico. During that time, there was a militarization of that border, very much so in a way that we see today, but through the construction of military forts and trading posts, American trading posts that were piling up against the border, perhaps in anticipation of a war that eventually led to all of that land now belonging to the United States. The architecture of these forts is incredibly interesting to me. It is architecture that I think is a hybrid between the conditions that exist, the cultures that were in conflict and living together and coming together and learning from each other. But this is an American fort constructed in Colorado entirely out of mud and logs felled from the forest. but very much a reflection of the indigenous architecture and later the Spanish architecture that came. So this is Taos Pueblo, not very far from the San Luis Valley, just actually about 40 miles south, which is built in the 1100s. And so it's this collision of cultures that for me is the most interesting, and the implications of it, how it creates a hybrid between language, between cuisine, and it is not always one without frictions. And so even in 1936, there continued to be a very perceptible border between what was perceived as the United States and something else. Colorado declared martial law, the governor did in 1936, and suggested that no one from New Mexico of Mexican ancestry could enter the state of Colorado, and placed border guards at the border between Colorado and New Mexico, despite the fact that New Mexico had long been a state at that point. And so they were returned back to New Mexico if they were found crossing into the border without proof of employment or proof that they were not of Mexican heritage. The implications are most interesting for me in the context of architecture, and how the architecture undergoes a kind of morphology based on the kinds of technologies that are introduced into the landscape. Earthen buildings built in the 1700s, later transformed when middle lumber and rolled metal come in, and today that same building, San Lorenzo, is transformed and frozen to a kind of historic state where there's kind of strange structures growing off the entrance. It's cast in plaster. It's removed the roof and reverted to a kind of more historicist condition. And in thinking about my own house in the village where I grew up for 7 generations, made out of mud, but I use it as a test bed to continue to teach traditions of plastering with mud, also making adobes, but also thinking about this in my practice as an architect for this house that we made in Marfa, Texas, that employs these kinds of historic technologies and current building practices, weaving concrete and earth together, making architecture in a way that takes building materials from New Mexico and from Mexico, lower bricks are from New Mexico, above are from Ojinaga, Mexico, because they were lighter and less expensive, saving cost on the wall, and not needing to bear such a structural load. Weaving them together in such a way that you can see the distinctions clearly between two building traditions, but also woven together simultaneously. Working in Marfa during that time, we also began to be exposed to the political conditions of working on the contemporary U.S.-Mexico border, a landscape that in many ways is a binary between the United States and Mexico, or Texas and Anglo, or wealth and poverty. And we were approached to work on a project with 2 artists from Berlin, Elmgreen and Dragset, on a project that kind of walked the line between all those juxtapositions and contrast, which was called Prada Marfa. And for us, that exposed another dimension of architectural possibility, one that is political. What does it mean to build a building in a landscape, or an architecture, or an installation that suggests a kind of vehicle that is recognized for selling some of the most expensive purses and shoes in the world, in a landscape where the historic shoes were made out of the yucca plant, which is prevalent in the environment, in a context where people walk hundreds of miles until their shoes wear out, and they have to stuff yucca in their shoes to keep on going. It's a project that draws from Andreas Gertzky's photograph Prada as its facade, and this is the building, Prada Marfa, built along a desolate road in the West Texas desert, holding the 2004 line of purses and shoes, not open to the public, but hermetically sealed as a kind of time capsule in the middle of the desert. But even in the construction of this building, we wanted to demonstrate these relationships and juxtapositions, because we felt that this was a future object of archaeology, one that would be uncovered, and maybe archaeologists would discover that within the building was present this tension between the very humble mud brick and cement mortar, and this dialogue between the two, which the US military introduced into the border because they were very accepting of the brick, but not so accepting of the mud mortar. And you find that in the construction of the military forts that were constructed in Marfa as the base to protect the United States along the US-Mexico border, and later you see these same buildings housing Donald Judd's collection of minimalist work in Marfa. Another outcome for us was the notion that these objects could become cultural objects. The buildings could become a cultural object. And what does it mean the moment that these transcend their own visits, but move into the realm of Instagram, for example, and the selfie? And so when Beyonce made this jump in front of Prada, it became the kind of signature thing you do in front of Prada Marfa if you ever visit there. And so for me, the borderlands were both a context in which we found two things. That project was completed in 2006, and there was a heightening of security along the US-Mexico border at that time. And in 2006, the Secure Fence Act was passed, which mandated 800 miles of wall between the United States and Mexico. So what we found was these conditions of horror along the border, coupled simultaneously with conditions of humor. Horror stemming from the militarization of the border, from xenophobia, the struggles between poverty and immigration, and humor as a response to those hardships, and as a strategy sort of to deal with the ridiculous nature of the border wall. And so this was what prompted our research and work on thinking about the conditions along the US-Mexico border and the construction of the wall. For those of you who do not know, and I find often people do not know this, there are 690 miles of wall constructed between the United States and Mexico currently. So when Donald Trump ran for president and campaigned, he would announce to audiences, "I'm going to build a wall," and everybody would clap as if someone finally came along to build a wall. However, there are already several hundred miles of wall at a cost of $4 million per mile. And in fact, this is one of the most expensive stretches of wall constructed over the dunes in California, called the floating fence. But $3.4 billion have been spent constructing this wall since 2006. And it's anticipated that $49 billion will be needed to construct and maintain this wall over the next 25 years. Again, this is not Trump's wall, which he has only built a few feet of. This is the wall that was put in place by the Secure Fence Act by George Bush, and really the majority of which was constructed under the Obama administration. I like to put that number, 49 billion, into an architectural context to think about what else that would buy. It could buy 300 Seattle public libraries, or 204 Disney concert halls, or 500 miles of the High Line. And put that into perspective when you think about the fact that there are 690 miles of wall built instead of 690 miles of High Line. I don't mean to suggest that we should build a High Line there, but one could imagine the kind of cultural investment that would transform a region that is in need of infrastructure around water, education, social infrastructure. In addition to that, since 1994, nearly 6,000 people have died trying to cross the border. And so the implications there are that the wall has pushed people further into the desert, and this is the outcome. Well, what does one do as an architect, and how does one participate? We had no idea, but since that time, since 2004, we began drawing and making models and producing images that would help us sort of memorialize in a way, or remember, or think about the problematics of the wall. And so these are just a few examples of them that we call recuerdos, or souvenirs, of a moment that we have to kind of remember what happened. And so there's sort of a progression of thought for us around how we might think of the wall. And so in 2006, one way we thought about the wall was what if we could do something instead of a wall? What would we do instead of a wall? And so some of the drawings we produced were imagining, well, why aren't we investing in solar energy instead of investing in a wall, for example? This is not to say that we should build a solar wall, but I think these drawings open up a conversation to lots of different possibilities, because this is the region that is the most fertile for harnessing solar energy. Or what if we can create wastewater treatment plants in landscapes where we have some of the most polluted rivers in the United States and Mexico? Later on, without the ability to stop the wall's construction, what do we do since there already is a wall in place? And this has been a question that is sometimes controversial, but if there is a wall, does one participate in thinking about construction in and around and on and the wall itself? So we produce drawings of life safety beacons that should be constructed to prevent deaths, that store water, that clean water, that alert border patrol so that they can possibly save lives, of thinking about transforming the really uninhabitable zone between El Paso and Juarez as a place that is an urban park on both sides of that wall that has been in place for a very long time, even prior to the Secure Fence Act. To think about the kinds of social infrastructures that could be constructed in those landscapes, binational theaters, for example, a binational library where the wall is converted into a bookshelf where ideas can be exchanged. And all of these images really come from stories that were already occurring on that border, or in some cases inspired by other borders. So in this case, there is actually a binational library on the Canadian-US border that is joined with an opera house. And I think it's now, I always forget which it is, but I think it's called the only library in the US without books, because all the book stacks are in Canada and the reading area is in the United States, or vice versa. Can we create clean water by harvesting fog, for example? Can we begin to ask questions about the wall serving as a vehicle for pedestrian and bicycle traffic east and west, since it serves as a barrier between traffic north and south? And so these are meant, in a way, to just ask questions about the possibility of what could happen. And I think they led to sketches and drawings that were really acts of resistance by pointing out the ridiculous nature of the wall itself. So, for example, in this sketch, the idea of a swing that people can enter in on both sides, and just for a moment swing to the other country before gravity returns them to the other side. Or a labyrinth that really speaks about the enormous complexities that are producing this wall. Or a teeter-totter that speaks to the notion that really what we do on one side has consequences on the other side, and there's a synergy between both countries and the people who live on both countries, and the border is actually this enormous fulcrum where we share these kinds of commonalities. Or in this case, a confessional where it sort of has in the entrance, the priest actually goes to the other side and the confessor enters and goes into the other side, but they're still bound by the wall itself. So the first confession of the sin is that they both crossed the border illegally. So these are the stories that exist in this book, Border Wall as Architecture. And these are the products and objects from that exploration that tell the histories. And so just to briefly tell of the few of the stories that are within here that accompany these stories about the origins of the oldest sport in the world played with a rubber ball, where players from each side keep the ball in the air, hitting it with their hips and sending it across a imaginary line in the sand, a very kind of violent game where people actually die because the ball is so heavy. And relating that to the playing of volleyball, a binational game that's been played since the 70s to celebrate binational identities and people coming together. So the wall in many ways has served as a vehicle to bring people together despite its intent to separate people. And here this is imagining constructing xylophones on the wall instead of constructing walls, that memorializes my friend Glenn Wayant, a musician who picks up sticks or mallets and plays the wall. He calls them weapons of mass percussion, to talk about the weapons of mass destruction that propagated the construction of the wall in the first place. And sometimes he actually gets Border Patrol to play along with him in his recordings. On one side of the wall, it may look like this: someone mowing their lawn in a domestic environment in the United States. And on the other side, the wall is sometimes used as the fourth wall of a house. And we produced a series of drawings looking at this system, where we would reveal the kind of construction systems on one side versus another, the size of spaces. So that's the typical size of a house in Juarez. This is the typical size of a house in El Paso. And we imagine this as a single house divided, in this case, dividing the bed. But these kinds of construction methods that are transform wood frame in one side, or adobe or concrete block on another side, are something that has always interested me and fueled a way of thinking about making. And so it also gave birth to a way of thinking about 3D printing. I gave a workshop on 3D printing today. And while this may seem like a strange transition, I want to just point out that these were both research endeavors that kind of came from the same mother, in a way, to think about how we could maybe make buildings using the most humble and fundamental building component, which is a brick. And how, if we use that technology to make a brick, how we might be able to make architecture for the 21st century, thinking about craft, but also about material origins. And thinking about how we wouldn't maybe make a printer that's larger than a building, but we would use a number of printers as a farm to make lots of parts that people could very easily assemble together to make complex objects that reflect a complexity of culture. And so some of the things that we think about are, let me back up a second. And some of the things that we're working on is that we're inventing materials for 3D printing that are ecological. And I'll talk about that in a second. Developing software and hardware. We're testing assembly methods that don't require specialized skill. And we think how to connect pre-industrial, industrial, and digital craft technologies. And there's a word that I wanted to share, and it's a fundamental concept called rascuache. And I keep passing that slide. But the notion of this word is that you do the best possible you can with whatever you have available, with the least available. It's a word that Chicanos use often to describe, let's say, I described it earlier as if you've ever been to a Mexican restaurant, for example, and they have a salt shaker made out of a beer bottle. Like that was really smart. It holds a lot of salt. You can use it. And there's a pride associated with that. There's a pride being able to do the most with the least. And I think this is a kind of how we think about not only the wall, which is sort of, we've given a poor situation, but how do we address it, given however we can react to it as designers or architects. But also, how can we begin to think about architecture if all we have are the kind of small 3D printers that you have on the desktop? And so this is the goal we embarked upon several years ago, and willing to invest in it to the extent that we produced objects that used an enormous amount of parts. In this case, there's 2070 or so parts in this, using only desktop printers, because we wanted to see, well, what are the issues involved there? What are the complexities? And so in this case, a building where the building instructions are encoded in the color. So we wouldn't have to negotiate 2,000 parts, but we could say, oh, red parts go here, blue parts go here, and we could assemble something very quickly. And we're also thinking about the ways that the machines behave so that we can control, oops, maybe I'll lower that. I don't know if I can lower that anymore. But we control the application of material in very specific ways. So we can make structural areas that are thick, or ornamental areas, or we can integrate the two and make objects sort of like that. But plastic isn't our goal. We wanted to think about materials that were alternative, or rascuache materials in a way, materials that we could find in the landscape. And you can see some of those upstairs. Upstairs we have objects made out of curry, out of tea, out of coffee, and out of cotton candy. And you can see and smell those objects, but we also made objects out of sawdust, thinking about the 7 million tons of sawdust that are produced every year in the United States from the construction industry. Salt, which is, there's hundreds of thousands of tons produced in the South Bay using only wind and sun. And this is something we call the salty glue, because it's made out of salty glue. Also ways to think about using cement, but using cement with very little water and very lightweight, that's fiber reinforced to make very large objects using a 3D printer. And so we've worked on developing materials for a very long time to sort of hack 3D printers. In a way, Rasquachi actually means to hack, maybe, to hack with pride, or I guess. But the material I want to talk about most is clay, and we did the workshop in clay today because it relates directly to my interest in earthen architecture, and it relates directly to the notions that it's within the borderlands that these kinds of materials are employed and used. And so in a way, the 3D printing technologies are a process that emerges from the borderlands also of technology and tradition. And how could 30,000 years of additive manufacturing by hand, by humans, transform into a contemporary practice of ceramics, for example? And so these are some of our earliest pieces from 2009, when we first embarked on 3D printing clay and realized, oh, we can put them in the kiln and fire them, and what does it mean for these objects to last another 100,000 years when archaeologists find them in the future? What kind of meaning could we embed in them, and what kind of meaning do they have implicit in their materials itself? And what would we make with that? Would we make bricks that insert themselves into traditional brick systems and they could hold water or plants? Could we embed air pockets and make kind of insulative bricks in some way? Would we look at past traditions like these traditional evaporative coolers, where you would set an enormous porous ceramic vessel in a window in an arid climate, and when the arid air passed over it, it would humidify the air and enter into the space and lower the temperature of the room on the interior of the building. And so we took that technology and tried to encompass it in the making of a single brick, a brick that had two levels of porosity, a micro porosity that we could calibrate with the material system itself and the 3D printer so that it sucks up water like a sponge and holds it, but also another level of porosity where air could pass through and thus humidify rooms. And we call this the cool brick. And it's a brick that has this relief so that there would be areas of shade on the wall, so you wouldn't hasten evaporation, but also could be held very unapologetically in any kind of mortar that holds the brick together. So these are our prototypes of the cool brick wall. Some of the machine behaviors that we explored on clay allowed us to make things that we never thought we would make. Objects like this, where it's just pinching off each layer of clay as it goes around, so it's kind of like a cactus or something. Or objects like this, which I don't know what this is, but it's just drooping and falling. And so the outcomes were just design research with no intent on any kind of function necessarily or purpose, but ways of exploring and investigating the relationship between the material, the machine, gravity, and these are some of the outcomes. And so sort of pushing the limits of what's possible in terms of texture. And we saved every single experiment we made just as a matter of habit, arriving at a body of knowledge that would allow us to further explore these in the making of architectural applications. In this case, thinking about how we can make wall cladding systems, for example. And these were a number of the early explorations in ceramic wall cladding systems. So using only clay and water and fire to produce a building skin potentially that could last a lifetime and beyond. We also begin to think about how we might consider the blending of materials. And that was actually prompted by our president, because I was working in Juarez one day when our president announced that there were a lot of bad hombres at the border. And I thought, oh, that's really interesting. There's bad hombres at the border. And hombre is a gradient between light and dark. He didn't say there are bad hombres at the border. He said there were bad hombres. So these objects I call bad hombres because they take clay from the Republican state of Georgia and clay from the Democratic state of California and blend them together in a way that shows both their distinction and their gradient and their relationship in both the details and the form of the object themselves. Thanks, Prez. But we're always thinking about how we might make architecture. You know, these are really experiments for us in scaling up. Not to say necessarily that these become buildings, but yes, to say that maybe those could become buildings, and how would that be possible? We had to embark on thinking about making software, and some of you got to play with that software today. And that software, which we call potterware, is designed for making pots. But really, the underlying basis for the production of this software was so that we could control a machine, because we also realized we had to make a machine. And we made a machine that could do a number of things. One, it could produce a bunch of pots. So all of a sudden, we moved into a world where we could make hundreds of objects with a single machine. But that very same machine became a machine where we realized we can make really big things. And so the idea of this particular machine, in contrast to many who are making machines to produce architecture, is that their machines are often bigger than the architecture it makes, just like a 3D printer. But ours was intended to be smaller, that you could print a room, for example. And so we also had to think about how we could have a continuous delivery of materials. And so then it's in a tube, but a year and a half ago, this is where we were. This is a human 3D printer. And so we're just trying to push clay, and so that's that. But as of just a few weeks ago, here's where we have arrived. We've arrived in a place where we are now able to just shovel in as much material as we want. In this case, adobe. So this is clay, straw, and water into the machines, and so we've scaled up. So fundamentally, this machine can print a room. And so we're imagining not only how this technology might be able to make architectural components that are at the scale of architecture, or environments, or rooms, or buildings, or structures, but we also have to think about where does that material come from. And so we've been doing a number of tests of how we can take the soil beneath our feet and convert it into a material that can be used in architecture. And so we've been doing that at the scale of pottery or earthenware, where we've just dug clay from the ground. And we've done that both in California, but also we were invited to India to do the same thing, where Google had designed this application where people coming to the museum in Mumbai could write down the most important thing they thought, the important word they thought that should be remembered in 100 years. And then we worked with pretty much the most famous potter in India who harvested local clay and made this clay for us. That's him in the front, that's me in the back. And we produced a series of objects that reflected hundreds of thousands of visitors coming into the museum and saying the words that we should remember in 100 years are things like a book, or mobile phone, or plastic, or computer. And at the end of the workshop, after, like, I don't remember, 10,000 students came through our workshop, 3D printer was one of the words that was the top 10 word of the day. And they're written in 2 languages on the single vessel. So this is before it's fired, and this is after it's fired and glazed. And it says book on one side, and it says book on the other side in Hindi. And so here are some of the examples of those objects that will be on exhibit in 100 years at the museum in Mumbai. If anyone's around, I encourage you to stop by. And we're also exploring ways of thinking about how to combine some of the traditions and experiments that we're doing. So in this case, we call this a jacal digital. And I see a student, we've worked on this a long time ago, and so now we've made this structure where it's semi-rigid, but we've applied the mud to it to make it even more rigid, and so you can see it under construction. And once that mud dries, and you can see it kind of quivering, once the mud dries, it gives it its ultimate rigidity. And so there's a tradition in New Mexico of making structures, and actually all over the world, you make them out of a plant material, like branches, and then you plaster with mud. This particular material is a plastic made out of corn, and then we covered it in mud, and this is the outcome. And so that same research that we didn't know what to do with, that wiggly research, gives this its structure. And it's also led us to some other experiments like this, which is now we're beginning to work with scientists to create artificial bird habitat off the coast of San Francisco on an island called Año Nuevo Island. Año Nuevo has a bird called Cassin's auklet, and they can no longer find nesting areas because of sea level rise. And so we're producing these artificial environments that are basically birds' nests, and the birds' nests have an entrance where they can come in. The bird lays its chicks there, and the chicks are really annoying and noisy, so the bird has to be on the other side of the wall. It usually finds that in nature, but it can't find that in nature. And then there's a little peekaboo area for the chicks so they can look out in the world, make sure there's no ravens or other animals that will eat it before it can exit and go out in the world. But it uses this technology that we did not know what to do with, which has these micro shading devices, which was really important to keep the nest cool, a double wall, and you can see that air can actually escape, so it's kind of ventilated. And so we've taken them last year out to Año Nuevo and deployed them, and so the first version of these are being tested already, and now we're working on the second version, which has a raven-proof lid. That's a raven-proof lid, if you didn't know that. A couple other things. Some scientists came into our studio and they saw all this stuff made out of coffee and car tire rubber and cotton candy, and they said, can you print calcium carbonate? Because calcium carbonate is what corals and coral reef produce. And they said not to create coral reef restoration as a project, but to demonstrate that higher acidity levels in the ocean actually dissolve coral and coral reef, and then decimate that habitat. So we were able to print out of calcium carbonate these objects that they are now using to teach the fact that these higher acidity levels destroy coral. And these are scanned coral from this organization called the Hydrus that goes around the world scanning the coral. But then they saw those crazy objects with all the loops, and they said, wow, that would be a perfect environment for coral to grow in. And ceramic actually happens to be one of the best materials for coral to grow in an artificial environment. And so over the summer, we've been working with them for about 2 months, and then we went into production of 4,000 of these seed pods. This is one example of them, and this is another example of these shapes, both 3D printed out of ceramic using different techniques, where scientists are using them in these test pools in the ocean in Baja California, in Australia, in Guam, and they're working. So the coral are attaching to them, and it's pretty exciting to see these environments being tested in nature. And so we're not only thinking about, of course, environments for animals, but also environments for humans. And so we've taken a number of these technologies and we did this project called the Cabin of 3D Printed Curiosities, because basically we took all the things we learned over the last 10 years and began to couple them together. So we made a building skin made out of 4,000 3D printed ceramic components that are woven. We call it a seed stitch wall because it looks like this woven seed stitch. This is actually in July at noon, where they're just reaching out and grabbing the sun. And thinking about, well, what's that building system like as a 3D printed building system? What do they hang on? Do they hang on a 3D printed wall backing? We also at one point did a project using Chardonnay grape skins, and you can see some 3D printed Chardonnay cups made out of Chardonnay grape skins upstairs, but we made this facade out of Chardonnay grape skins and sawdust and cement, and it holds succulents that do well in the Northern California climate. And this is really a test bed for us to test our materials outside, their longevity, how well they work in the sun. And so this little cabin of curiosities is nestled in a backyard that's a response to the relaxation of zoning in the East Bay, because I don't know if you're aware, but San Francisco has now surpassed New York as the most expensive place to live in the United States. And so this relaxation is to allow people to build up to 1,200 square feet without going to the planning department or employing an architect. And so to make these secondary living units in the backyard. And so we did this in a response to that condition as a realm for experimentation. And so this is the 3D printed cabin of curiosities. The interior has a translucent 3D printed skin that is backlit with LEDs, so the colors can actually be set a mood. You can see what it looks like in the interior. But almost everything is 3D printed, the furniture, the coffee table. You can actually see the coffee. What's upstairs is on the coffee table right there. Whoops. I think it's a copy. So the Chardonnay cups and the coffee pot and coffee cup, using that same kind of software technology that we're working on. This is the interior at night, backlit, not with a color, but with pure white. And it transforms into a sleeping area as well. And it kind of sets the mood of the house right before one goes to bed. Yeah, I like to sum up with this slide, and I think it sums it up best, because I often think that rather than seeing building with earth and clay and 3D printing as two sides of a technological spectrum, I'm interested in bringing them together. And I think my goal is to think about how we can make work that bridges the borders between art and science and architecture and culture and politics, with implications in craft and sustainability. And I think that one way of looking towards the future is actually looking at the past and seeing what we've done. So thank you.
I was going to say dubious, but I don't know if that's a good word. They're difficult tasks that somehow kind of, I feel like I have to, I don't know why, I don't know if I have to. I just have to like ask you silly questions or ask for the help of the audience in trying to sort of make sense of, I mean, well, it's truly an amazing production, right? Can you hear me? Yes. Yeah. So there's no doubt in my mind of the high quality of the work that we see, and also the sustained inquiry at so many levels that it's very difficult to just grab one strand of what we see here to try to weave a coherent sort of understanding on what is it that you are actually doing, all right? Because it seems like that you're doing so much. So maybe basically to start very in the most sort of basic or pedestrian aspect, can you talk a little bit about collaboration? How has this sort of research that you've done sort of affected the way, because you also teach, right? You approach design or thinking sort of about design, not only as a practice, but also as what I assume is a collaborative practice, because we only see you here. But I wonder who's behind all these. I mean, when we see the images of traditional buildings, we always see a community building, right? But when we always speak about these things, we only see one person. So I'm always wondering, well, okay, within these new practices that we are claiming to be more accepting of diversity or difference, right? Do we need the whole panel of everybody here? Do we bring the community? Are you the community?
I'm not the community. I mean, to kind of reveal like that certainly no one person could do this all by him or herself. And I have a partner, Virginia Fratello, who is my collaborator. I would say that we are the people who instigate all this work, but it's certainly not the people who produce all the work. We have employees. I have a position, as does she, at 2 different universities, and so we also have graduate and undergraduate research assistants. We have the wealth of knowledge from the university itself, and anywhere from clients to fellowships to grants that allow us to produce the work, often in collaboration with scientists, material scientists, material experts, and also, in the case of the machinery, what I would call an industry partner, a partnership with someone who I approached several years ago, and we found a synergistic, symbiotic relationship because he had just started working on these printers, and I had started making crazy stuff with his printers that got attention, so more people started buying his printers, and he said, hey, print more stuff, sending me printers. And then I said, I have this idea for a big printer, and he said, well, let's build it. And so there's, there is an entire too numerous amount of people to mention in the. If you go to our website, emergingobjects.com, you can see the list of all the people who collaborate, and sometimes it's enormously lengthy. So there's a machine behind this work and a community behind this work.
Not that you need to comment, but it just struck me in your presentation that it seems that their particular fields are very interested in this work, but it struck to me, perhaps, and maybe I'm wrong because I'm not an expert and I'm not engaged in what you're doing to great detail, but it doesn't seem that the field of architecture is actually, or the production, the building of buildings yet. Are you seeking collaborations with that field also?
Well, the way I would approach that answer is that we have aspirations to integrate into the field of building and construction.
Mm-hmm. The field of construction.
The field of construction, and architecture and construction, I meant to say. But there are frictions there, and some of the frictions are really pragmatic. Like, for example, we get lots of inquiries from the building industry saying, "Okay, we want some of those 3D tiles that you make. How much do you charge per linear foot?" And this is not a linear foot question because we're thinking volumetrically. We have to charge volumetrically. So what kind of design do you want? How thick do you want it to be? What kind of pattern? This is talking about machine speeds now. And this is all language that builders don't use right now. They say, okay, by linear foot, if this costs, tile or flooring or by the square foot. But when you talk about volume, it changes the game. And so those are often that's often the resistance. But the way that we're aspiring to enter into this is maybe on 2 fronts. One, we recognize that this stuff is expensive. It's like, if there's any architects in here, it's like Bizaza tile expensive. It would be expensive as cladding right now. Even though what I think we have done and what our main primary innovation is we've lowered the cost of this. So it used to be that you could buy 100 pounds of 3D printing powder for $3,000. And we wanted to question that, and we can make 100 pounds of 3D printing powder for $40. And so, but that's really expensive to make wall cladding, right? But it's within the realm of that right now. But on the other front, we want to approach ways of thinking about how using recycled or upcycled or sustainable materials or traditional materials can help us move into that realm faster. And that has implications in thinking about building for different economic groups as well.
So I want to pick up on this notion of the frictions that you've encountered, even in the realm of language, how maybe even is the realm of language, which today is a highly contested and politicized field, but we won't go into there yet. Every time I hear, not necessarily you, but also have heard you, hear these kind of presentations, they start to verge on, if I may, into the heroic, into these kind of grand sort of forces of research, of science, of investigation, of humanism, and I wonder about failure and how failure sort of within these, from experiments, from collaborations, from language, what's the role of failure in these kind of narrative that that are always, I think they're there, but they're actually never sort of brought into the equation, into sort of exposure. Can you talk about failure?
Sure.
How much failure have you had?
Where do I begin?
What's the most?
Where do I begin? I don't know how many people attended the workshop today. That's a good example of failure right there. Like, I was a little bit. So the machines were not working. I mean, basically, you experienced a week in my life compressed in 2 hours. Like I had to step out for a moment and take a deep breath and call somebody. So like, what is going on? Because I could not figure this out. But I would say that where failure is most present in this work is my luxury as an academic and as a researcher to take enormous risks. And along the way, there's enormous amounts of failure, right? They don't show all the failure, and in some cases, you're seeing like those objects. That's the wiggly objects where the droopy clay and so that all emerged out of failing. And we saw today in the workshop where, at least I was very nervous, and we were printing something, and it had gone up an inch, and the person said, "Oh, that looks ugly. I think I failed." And then we let it go for another 15 minutes and realized that the repetition of that horror all of a sudden turned into this beautiful object. And so, in a way, I think this is what's happening. I mean, it may sound heroic, but I think there's patience. This is the work of 10 years. This isn't the work of pressing a button. And so I think that we're just seeing in the accumulation of failure, and we're seeing in both, in this really, I love this photo, and it was taken by Matthew Millman, who's a very well-known architectural photographer in the Bay Area and throughout the world, actually. Hidden in that are so much problems that maybe only I can see, and that I don't want to tell you about because they kill me inside. But I think that's the thing. I have the luxury to take risks and fail, and from the failure emerges some promises that I think I'd like to continue with.
But I think it's very important because, I mean, these type of projects are based on what you say, the possibility of failure, right? That it's not something that everyone can take. So for me, those hidden histories, the alternative histories that are behind these, these highly elaborate, highly eloquent, and truly beautiful assembly of parts. I always wonder, well, okay, but where were the failures, right? Where are the limits of these type of productions? It's when we start talking with shifting into the realm of architecture, right? Into the demands of an established construction industry. I do wonder, well, what are the limits? What are the limits of these nascent technologies, still a nascent technology, right? And how those limits are sort of negotiated in a way. Like, for example, I cannot, point out that, that the need for the hybrid, as you mentioned, right? That these things are actually hung as element, right? And try to sort of negotiate sort of that as a tactic of producing these new technologies. And I guess I always wonder, I've always been fascinated, and maybe there's no correlation to this, but late in the 19th century, when steel and iron was being sort of introduced, we have these kind of attempts to incorporate these new technologies into architectural works, into large works or small work and design works, right? And suddenly it produces a highly decorative sort of view of the incorporation, basically what we historically, stylistically would call Art Nouveau, right? And suddenly, and that can be seen as a way to negotiate, right, the introduction of new technologies. And I was fascinated by the decorative aspect of this type of new technology, right? Why is it that these negotiations with technology always, or in these many cases, maybe even yours, right, have a high degree of decorative component? And I always wonder historically, well, why is it? Is it this negotiation of technologies that actually create this kind of decorative impulse? I mean, could you produce something that is actually not decorative at all?
Well, I don't know.
Why is everything that I see here, sorry, why is everything that I see, I'm being harsh, but why is everything that we have seen, at least for me, I would say, is this such a high decorative impulse behind this that for me personally, it's a big question mark, to tell you the truth. Yeah,
I think that's a really good question, and now I'm thinking about it, but and I probably have to take some time to reflect on it, but my initial response is that that which is not decorative might fall in the realm of structural and infrastructural, let's say. And so maybe if I just answer, not from my perspective, but from a historical perspective, perhaps it's because one would want to put to the forefront the potentials of that technology. And if it resides hidden, then one doesn't see it clearly, right? If I made the version of this that accepted the technology for its structural capacity, right, and it was hidden within the walls, and no one saw it, then it wouldn't matter. It has to reveal itself, and when it reveals itself, it has to have a face. It has to have a facade. So that's just what's going through my mind right now when I'm thinking about it from that perspective. I think there are other reasons for me that I'm thinking about it this way, and it's also because we have made structural experiments. I showed one or two pictures of it, this large-scale concrete structure that was printed this way, and that was just a lot of work. It was just really a killer in terms of making it and producing it. But I also think that in terms of how 3D printing might enter into the construction industry, if there's one step that it could enter into quickly, it's actually in surface. Because right now, metal is enormously expensive to print. Concrete is not only expensive, but slow and ugly and very imprecise. But in terms of the precision of 3D printing in a skin, then it becomes very plausible, and that skin can be articulated to the extent that other technologies can't do, and so then it promotes the potential for making what you're describing as decoration. But I would say that it's also, what it's really doing is it's demonstrating the potential of the technology, and it has the capacity to do things that other technologies couldn't do in the past very easily. Yeah.
I don't think that, I mean, it's not a negative. I mean, this decorative impulse is not necessarily a negative thing. Absolutely not, right? It's actually the attempt to create new languages of construction and new ways of understanding space that allows us, right? I'm going to make my own self squirm for a moment and kind of shift it a bit to the border and thinking about how the failure of the border, like there's a condition where there's a failure, in my opinion. The border wall is a failure. And so how does one address it? And my work has in fact been criticized as being decoration on that wall.
fine. I accept that. I think for me, there are deeper implications of the work that are really talking about a conversation and not a proposition, if that makes sense. I'm not trying to put pearls on a pig. What I'm trying to do is say, here is an issue, and let's talk about it and think about it. And the images have the capacity to hopefully allow us to have that kind of conversation. So in a way, I think both failure and decoration kind of transcend both projects.
Mm-hmm.
Did I just?
It seemed to be
check.
It seemed to be convincing. Yes. Okay. Let me keep. So.
Did I make you scream?
Not yet. So, if such is the case, then I would like to ask. So, why have? And maybe I haven't seen it. Maybe it's there. But why haven't we seen a project that engages printing technology for the border? Why didn't?
Why didn't I? Yes, because I am working on this project, in fact, and I realized when I went through this, I left out a very important slide, a couple of slides. But I have been working on a project that builds upon getting local soils, but in this case, collecting soils from both sides of the border, living up to the bad hombres in a way that, I thought the best version of that was if we could get soil from Mexico and soil from the United States and print these objects that were a reflection of that relationship. And in this summer, we collected soils all along El Paso and Juarez, and I was really bummed that I left out that slide, but we just test fired them. And the range, just within El Paso and Juarez, the range of complexions of the soil was amazing because it was almost like, you could think about it like skin colors or, from white to brown to reds. And I actually couldn't believe that. And so we are returning to Juarez in October to take that big machine that makes Adobe, and at the site where Chihuahua and New Mexico and Texas meet, so these 3 states meet in this one place, there is a building called Casa de Adobe. And this is the building in which the Mexican Revolution started. It's an Adobe structure. And so in October, we are going there to Casa de Adobe to 3D print this enormous Adobe structure. So now, I mean, this was never, in some ways these are 2 sisters of research that are born from the same mother, but now we're seeing the common genetic code that's starting to stitch them together, I hope. Yeah.
Is it going to be a beautiful intervention? Sorry, I couldn't resist. Be careful how you answer.
Okay, I think I got this.
Yes. Take your time.
If we think about design beyond the visual sense, then maybe I hope it is, because there's a poetic behind it, there's a history behind it, there's a technology behind it that might transcend the visual. I would like to think that we can address the visual sense in design, but you see where our technology is, right? I don't know, you saw that thing going plop, 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 and spitting out those balls of clay. I think that's pretty beautiful, but also that could be perceived that's where we are. That's the state of our art. And hopefully it's the layers of meaning that make something beautiful.
So, since we're at the border but I wanted to open it too.
One more question and then we open it up.
Oh, okay, good, yeah, because it's like, well, we can just open it. Let's just open it.
Let's open it.
Let's open it. Yes. Okay. Since you answered the beautiful question quite beautifully.
Talking of layers of meaning, I think the objectification of the landscape is really fascinating, and I was just wondering if you've explored polluted landscapes as a medium.
Have we explored polluted landscapes as a medium? I mean, I've definitely thought about them. I've thought about how you could take unremediated soil and use that in 3D printing. I haven't done that I haven't done that yet, but I think about it. I think about what it means to move into a landscape and what it, for the objects to have an embedded residue of its history. Yeah, but I'm happy that you reminded me of that. Thank you. I mean, while the microphone's being transferred, I would say that in a way, the sawdust, for example, or the car tire rubber, or these kinds of materials, these are landscapes. These are landscapes from the landfill often, and so we're getting that material and we're upcycling it, for lack of a better word, into something else potentially. Yeah.
I'm curious about these larger structures. For instance, the one on the image behind you. Mm-hmm. Is that structurally 3D printed, or it's just the cladding? It's
just the cladding.
Okay.
It's just the cladding.
And so what's the largest structure that you've printed? It is structural.
Right. The largest structure that I've printed is the one on the cover of the book right there. So that's a structural object, and it's made out of fiber reinforced iron oxide free Portland cement. Iron oxide, it sounds fancy, but it just makes the cement whiter. It's used in swimming pools and that sort of thing.
And you say that these are basically impractical financially, except, or in the Bizaza territory. Yeah. For some, can you put a figure on that just to help us understand what that means? If you were, to produce something of that scale, what does it cost, and how long do you think it'll take before that technology becomes affordable? What will it take?
It's a question that I'm trying to answer a lot because we get approached to do this. I'll be very transparent and say that this particular the making of this particular project kind of fueled a lot of this research by the fact that it helped me produce a laboratory. And so this was sponsored by a Thai concrete company who said, could you make a formulation with our material? And they sent me the material. And if so, we want to make a demonstration that one can 3D print using our material that we mine in Thailand. And so they sent $150,000. $150,000, I spent several months finding machines on eBay and hacking them, hiring graduate students to help me press print and to process the materials, and so that from start to end took a year and $150,000. Now that said, to put the pipes in place, that was a long process just to make the lab itself. So that was half the battle. I think now if someone came and said, well, make this again, it would probably be a fraction of that. Because the infrastructure is in place, but that was probably the big investment on that front. Some of our other technologies, like making the walls out of clay, which are not structural, and even if we did make them structural, like we 3D printed bricks, for example, I think that could be pretty reasonable because the robot's doing a bit of the work and it's just clay, and so that starts to move into interesting territory because now we can use this machine to say, let's make a bunch of, I'll call it quote unquote bricks at a time, and we have a delivery system where we don't have to stop and fill a tube and put it back. And so I haven't had the opportunity to test that yet, but I think that the prices would go substantially down. Yeah.
Hi, how are you?
Hi.
So I don't have a decorative question, but I have a question about, you invited us to Mumbai like in 100 years. Hopefully I won't be here. But I want to know, are you going to encode in these structures and these objects like how you made them and it's 3D so people in the future knows this? So since we're still like grappling with how the Maya ruins were made and the pyramids were made and how they were moved and stuff like that. It's a simple question, but are you going to encode it in there, or I don't know. Is that a question?
It's a nice question, yeah. It's a very poetic question.
I'm just a regular artist, so I'm not sure. You guys are probably architecture.
There's no such thing as a regular artist. No, that's a really nice. It's more than a question. It's actually kind of a challenge, right? You're thinking that this is important. I actually think it's important too. maybe I just haven't thought about that. I have a friend who is a potter, and he makes cups. And he's actually made 18,000 cups, and he gives them away. And at the bottom of each of his cups, he puts his thumbprint, because he knows that some of these cups are going to last for 100,000 years, and sort of if that thumbprint is going to be a record of his existence in the future. And so I don't know if your question is better than my answer, because my answer moves in the territory of, like, pharaohs used to write their name on every brick. And I think my answer is like that there's a name on every brick. I don't want to put my name on every brick. Saddam Hussein, when he restored like one of the oldest structures, he made sure that his name was written on every brick in the restoration. But I do think it's interesting to think about how instructions might be embedded in the objects that one makes. How do you, if I'm thinking about the proposition that this is future archaeology, then maybe I should have some kind of dialogue with those archaeologists and talk to them. But it's also that's cool. But it's also very lofty of me to say that an archaeologist would care, maybe they just wouldn't. Let's dig past that so we can get to the good stuff. Thanks. Any other questions or, yeah?
You said you've studied the Mexican border wall, and it's something that's kind of really interested you as a kind of point to kind of jump from in terms of exploration and design. Is there any other project or kind of tension that you see at the moment that you would maybe consider as your next project? Are you done with the Mexican border wall, or are you still kind of, are you still pushing to kind of develop what that means?
I think in regard to the wall project, it's evolving, and it's taking me in directions that are unexpected. I'm pretty interested in regards to the wall. I'm interested in a project that accepts that there's no wall, or that imagine there's no wall, which I think is the fundamental big question. Like, what happens if a president comes around and says, tear down this wall, and this wall comes down? What then? I think this is an amazing opportunity for designers, because one has stitched together ecologies and cities. For me, that's an enormous project, one that I don't think I can take on by myself, but one that I'd actually like to unleash on students, to say, if the wall came down between Juarez and El Paso, what does that city look like? How is that city a possible city? What is that world? How can we imagine and propose those worlds? So that's one. Another thing that interests me is the notion of the past borderlands, because I'm only coming into the realization, I think, in my lifetime, that I grew up in the borderlands. I did not know that. I spoke a different language. I speak 2 languages. I eat different food. But I never, even in junior high, I was like, I don't get the pilgrims thing yet. What's the connection here? It just wasn't making sense to me. And I think it's just now that I'm realizing, oh, this was the borderlands, the lessons that we could learn from understanding Colorado, New Mexico, Nevada, California, might be applied to how we think about relating to what's the borderlands now. I mean, I think there are lessons to be learned. And maybe the final one that I'm super interested in, but I don't think I have the energy or capacity to do, is marijuana. Because I'm from Colorado, and there's legalization of marijuana, and there's some really interesting territory to think about regarding marijuana. Like, for example, there's these enormous suburbs, and marijuana growers are buying houses in these suburbs that they're using to grow marijuana. And so what looks like a suburb in Western America is actually an enormous grow farm for plants. It's agriculture. And that's pretty weird and interesting and strange, and the ramifications for architecture. And it extends beyond that. That's just one example. So, I mean, but something has to like really pull you in for the obsession to roll, right? But somebody's going to kind of fall in love with that topic, I think, and it's going to be some interesting work that's produced out of that. Yeah.
Thank you. I want to thank the Cooper Hewitt for hosting us this evening. I found your presentation moving in certain respects. And I say this as a Canadian who grew up in New York City, who was in Rio de Janeiro, and as a tourist. And I remember seeing the slums as I was a tourist. And as I was listening to your presentation, I thought, well, what if you had an agreement with the Brazilian government and 3D printed housing for people in Brazil who will never be wealthy? So I didn't expect to ask that question, but that is my question. And thank you for your perspective this evening. Yeah. I didn't expect to be as moved as I was, and I say that as someone who grew up here. I'm a New Yorker, even though I'm a Canadian, so I'm sometimes nice.
So, yeah, the question is, well, yeah, what? I think the larger question is that of what can this application be used to help? Can 3D printing be used to help, right? Like, make housing. Well, you're saying that if the Brazilian government hired you to make housing for people who couldn't afford housing, right? I think that would be fantastic, as long as I was able to produce something that was better and that could help. You know, I'm not entirely convinced by my own. You know, for me, this is research. Like I'm questioning it constantly, trying to figure out, does this work? Does this not work? How is it failing? How is it succeeding? And so I can't make any promises or claims. I'm actually not as heroic as you might have perceived. But I'm optimistic about it. So am I optimistic that the technology might be able to be used for that? Yeah, and I would love to do that. I think that would be great. You know, I often reflect that I went to school to become a doctor, because I didn't know that when I went to college, I wasn't on a college trajectory, and I thought, oh, if you go to college, you either become an engineer or a doctor. Which one do you choose? I said, doctor. And so I didn't do so well, but I think I went into that realm because I was interested in helping people. So I'm trying to find that path by which architecture can actually serve kind of a social agenda, and so those are my underlying aspirations. So yes. Okay, make a call. Thank you.
One more question.
If there's one more question, maybe. That was a nice, yeah.
Sorry, so this is the last question from another Canadian, and it's actually one who is a pharmacist who thinks that this is the most interesting thing in the world, right? So I have no artistic background, no architectural background, so it's a very personal question based on what you just shared with us. How did you go from going to college to be a physician to this? How did you make the change? Like, what? Can you please explain?
I wasn't very good at the failure, yes, failure is the answer to that question. I don't know if that's a satisfying answer, but I would say that, you know, growing up where I did, I grew up on a cattle ranch. To be honest, I could build a house by the time I was 15 because my dad was a builder, and he would make me do this. And so when I discovered architecture, I thought, oh, this is easy. Or I thought it would be easy, but what I learned was that there was a much higher bar that's set for architecture. That it's a very idealistic profession. In some ways, like law, there's an idealism behind the profession. Are we able to achieve that in the profession itself? Often not, but there's the aspirations for it constantly, and so pushing against those aspirations has been what I've had the luxury to do as a professor. So that's how it happened, I guess.
Thank you.
Thank you. Thank you, Patricio. Thank you, everyone. Thank you, Christina.